Okay, sequence of lean implementation. I'm just going to go through some. These are some things that I have seen that I kind of feel strongly about. Not strongly, semi-strongly, and they may be right or wrong, but I'm just going to give you my view of it from what I've seen. And you know, I've worked with a lot of different companies, and I've worked for a couple of companies, and it's just my sense of how would you approach it. You're not going to have to do that likely for a few years, but at some point maybe you'll get involved with how you'll go about this. So communication from the plant site leader, the intent on transforming to a lean system. If you recall, the first one, remember the lecture on leadership? People buy why we do things, not what we do. So it's really important to communicate a vision from the leadership of the plant, from a plant manager. And if that doesn't happen, if he delegates that or she delegates that to somebody at a mid-level, it can't work by definition, as far as I'm concerned. Just can't work. Train all members of the organization on lean principles. Design and implement a continuous improvement system. Now, the reason I want to talk about that, you remember we talked quite a bit about a continuous improvement system. There is no need for lean implementation to do this. And it really converts the culture toward thinking we have say and we have authority and we have the ability to get things that we need and we can participate. You can do this immediately in an organization because every organization and everybody with every job has multitudes of things that they can do to improve. The problem is they don't know that they're allowed to do it. No one listens to them, and they have no voice. So what better way to start evolving the entire workforce towards lean than to put a system out there that invites their ideas to solve problems. All processes have opportunity. So if I walked up to you and you're working a job in a plant and I said to you, and I like to say this to people when I walk in a plant, if they say, yeah, we do continuous improvement, or they don't do continuous improvement, I'll walk up to the employee and say, your job that you're doing, your job is perfect in every way and there's nothing you need. And if you had any ability to think or change it in any way, you wouldn't have any ideas because it's so well done. And typically, if I ask that question, people laugh. They don't even respond. They don't go, well, no, there's possibly things. I think there's ways that we can improve. They certainly don't say, oh, yeah, everything's perfect. But they typically, when you ask the question that way, people just laugh because it's such a ridiculous question. So what that means is you give them a way to get those small things that they need, and you start converting the workforce towards thinking that they're problem solvers. So in my opinion, this is one of the first things you can do. Value stream, map all product families. Remember what we talked about, that we would like to know what is the lead time on all our products. Most organizations have no idea what their lead time is. They don't even know what lead time means. Heck, we had to argue in here quite a bit about what lead time means, right? It's not a common thing for people to understand. So right up front, it's pretty important to do this. We did it at a company not to be named that I work with. And if I remember correctly, the processing time, now imagine the shock if you work in this company and you have no idea what lead time means. Their processing time was 810 seconds. Their lead time was 45 days. So when you go through that analysis, they immediately, the whole organization, they're like, what are you talking about? This is insane. How could our lead time be 45 days? And then when you explain to them how lead time's calculated, and even more importantly, when you explain to them, it's how Taiichi Ohno and all lean organizations measure themselves, so it is a standard for lean, then they may go, wow, what's that mean to us? You know, so now you at least have them thinking that they've got a serious problem relative to being lean. And they've got a system deployed that they're beginning to evolve people toward a culture of problem solving. So establish your current state, lead times, and then engage the organization in Hoshin planning. Remember Hoshin planning? Again, the why, right? It's the vision of the company. That's where we develop the vision. Who do we want to be in 5 years? Why are we even here? What is our purpose? It's back to that why thing again. So you're establishing the why for the organization, and then you're communicating that to everyone. Here's the why. Again, back to the leadership lecture. People buy why we do things, not what we do. And this one I think is important. This is a hard sell because when you tell the company that their lead time's 45 days and their processing time's 810 seconds, they don't even know how to process that. When you tell them this should be a primary metric for the entire organization so that it deploys everyone towards lead time reduction, not there yet. You haven't implemented a lean system quite yet, but everybody understands our purpose in living here is to take this 45 days down. And if you recall, lead time drives everything. Lead time drives all the components of a lean system. You cannot reduce lead time without Jidoka and without just-in-time. Can't do it. So if it's a primary metric, we are either going to fail in our target or we're going to begin implementing lean. Kind of good to have that out there up front. And then, of course, establish all your KPIs or key performance indicators for the organization, cascaded down. That's kind of part of the Hoshin planning. So now what do we have? We have our metrics in place. We have the vision, cascaded. Everybody understands what we're to do. We've deployed our entire workforce in problem solving so that we can evolve the culture. We're building a nice foundation. Ensure the metrics are visible and displayed in all areas. It can't be top secret information. Every day we need to see what we're doing and understand what the requirements are. Establish a standard for problem solving and train. You know what this means? A standard for problem solving. Anybody care to explain what you think that means? Very good. Very good. Or 5S, right? Or 5Y, I'm sorry. So 5Y, A3, 8D. There's many different very well-structured problem-solving processes. And remember what we talked about Taiichi Ono? Taiichi Ono standardized the way people think. In other words, he harnessed the energy of the whole organization and structured everybody to a common way in which they do problem solving. So if we had multitudes of problems in here and you all used a 5Y document, as simple as that is, I can be assured as an organization that everybody has a structured way they think through a problem. I don't have a randomness. So we got consistency in the way at which we look at a problem and walk through a problem and logically think through it. Because otherwise it varies wildly from person to person. So wouldn't it be a good idea to say, hey, we're going to be doing this lean thing and we would like the maintenance organization to use the 5Y method, and we're going to train you on it. It's pretty simple. For every time we have a machine down more than a half hour, you must complete a 5Y analysis. That's pretty powerful. Without that, what happens? Machines break down, machines are up, but there's no consistency about what people are doing about it, if they're even thinking about it. They could be accepting the problem and living with it because that's just the way things are. Now you have a document that requires a response, and it requires it in a very structured way. Do we need to be lean to do this? No. So we can do that up front. It's more prepping the system, putting things in place that's going to support the activity. Assess the preventive maintenance system. Most manufacturers are weak on the preventive maintenance method. I've seen this quite often. You can walk into it. You've seen it as well. You can walk into a tier 1 international global company, auto supplier, and it's remarkable of how it's missing basic fundamental systems. So I'm not even talking about predictive. I'm not talking about vibration analysis and thermography and trying to understand what could be happening. I'm just saying make sure you got the blocking and tackling fundamentals in place, because most organizations absolutely don't have this in place. And remember the formula, tack time minus allowance, right? Remember allowance, to me, allowance means OEE. OEE is a large part of this PM problem. So if you're really going to reduce the overspeed, ultimately one of the key factors is our equipment systems must be highly reliable. And if you want highly reliable equipment systems, you better have a very good system in place to drive improvement. Do we need lean to have a good PM system? No. So put a PM system in place, evaluate it. And this is really key. We went through this in Mobile with Teledyne. Scrutinize PM requirements by asset. You may have 20, 30, 40 key monument assets in the shop. When you look into them, you might find that the PMs are garbage. It may very well be that they're way overspecified. It may well be they're underspecified. And a lot of times an OEM will say, do these 10,000 things so that we don't have to cover warranty. And then somebody foolishly puts all 10,000 in the PM schedule. They can't be done, so therefore none of them are done. So we're not putting the key requirements of PM in. And I'm going to give you an example when we did this in Teledyne. I say filter example. We got a guy from Detroit come down, look at this. Of course, he looks and laughs that it's non-existent. So he starts going through every asset in the shop, looking at the PMs, and they're garbage, just full of garbage. He starts cleaning them up one by one. And then he said, Tom, you're going to get a kick out of this. We had these filters. They were called smog. And they were above all of the machines in the machining shop. Great big things. I had no idea what they were. I just saw them up there. And he said, you know all those little units that are above all the machines in all the shops? Smog? I go, yeah. He said, you know none of them work? And I go, no. He said, do you know why they don't work? No. He said, because the filters are clogged in all of them. He said, do you know there's no PM requirement for those? Do you know nobody even knows they're not working? And I go, good find. What else do you got? Now, what does that tell you? Here's a system to filter the air. That's probably why the shop seemed a little bit foggy when we'd walk through it at times. And this simple system, changing a filter, wasn't being done, which shut them all down. What do you think about the key pieces of equipment that are machining crankshafts? You think those are probably pretty good? This is the organization that we inherited. I'm guessing most of the assets and the requirements around them are garbage. I'm guessing. So this company we're working with now, I see them and they tell me that the big problem they're having is they have a lot of downtime. Lots of downtime. And it was to the point where the person explaining this to me was visibly stressed about this. You know, almost like, I don't know, I'm not sure if this doesn't correct itself, if I'll be here for long. Didn't say that, but I just felt it. And I said, well, what is wrong? He goes, I I don't know, I don't think that the maintenance people, that we might not have the people that really understand these systems. So you have a manager, you're shutting equipment down, it's putting the company at risk, and they don't know exactly why. So you think assessing the preventive maintenance system might be a good idea before we implement lean? Something we need to drive OEE with? And this is my example for the 5 why. We did this at Chrysler, we did this at Teledyne. Define when to use a structured approach. For example, for each loss over 10 minutes, a 5 why analysis must be completed. Typically, response to failure is an evaluation of the PM schedule and subsequent adjustment to the schedule. So you go do the 5 why and you look at it. So why did this break down? It broke down because the belt snapped. Why did the belt snap? Belt snapped because it was old. Why was the belt old? Because it wasn't replaced in the adequate time. Well, what does PM schedule say? It says change the belt every 2 years. Okay, response to 5 why. Change that to every year. How much is a belt? $5. Change the belt every year. Adjust the PM schedule, put it in the PM schedule, and now we think with this simple adjustment, we probably won't see this failure again. So we go through the system, we purge it, we put the proper PMs in. Now 5 why analysis, we're continually evaluating that system to see if it's giving us what we want, making adjustments to it. Now think of this. We got a system in place now that's going to drive OEE. We got a system in place that's going to improve uptime. We may not do it effectively, but we have a system. Without that, we have nothing. We're victims. Implement a transparent system. Software programs offer dashboards so all can see the compliance level. This is pretty common. We implemented this, not this exact system. Let's see. I'm sorry, before I get there. Measure OEE, mean time to repair, mean time between failures. These are key metrics for a PM system. Make sure they're well done, make sure they're well understood. Make sure there are targets, make sure the maintenance organization has responsibility to improve it. Implement an escalation, sorry about that. Implement an escalation process for downtime. We did this at Continental also, at Teledyne. So if the machine's down half an hour, I think we had it 15 minutes, contact the first level of escalation. So that'd be a text to a group of people. Hey, group of people who might be able to help us. Asset A has been down 15 minutes. Okay. Do you need us? No. It's a requirement. It's a standard. We let you know. Oh, okay. Well, we'll come over and take a look. Okay, yeah, we're working on it. We should be good. But I'm following the standard. Half an hour. Second level of escalation. Asset A's been down a half an hour. Everybody knows. Hour and a half, the next level of escalation. 2 hours, president of the company. Asset A's been down 2 hours. Now, there's never a surprise as long as people follow the standard. Equipment system goes down. Everybody that needs to know at every level at a certain point will always be informed as long as the standard's followed. That's very powerful because otherwise an asset might be setting for a day and a half. And then you go talk to the person, what happened? We're running out of parts. Oh, this thing's been down a day and a half. Why? Well, this happened and we ordered a part and Joe doesn't know what he's doing. Well, wouldn't that have been good to know immediately? And everyone in the organization within 2 hours are aware of the situation? And could there have been things that might have been done to assist that person if everyone was fully aware of it? So the escalation process is a standard to ensure everyone's totally informed about a problem that could be impacting the business. Very simple to do. We just simply had the groups on pagers. We could select escalation level 1, hit the button. Everybody knows. No one can say they don't know. Very powerful to keep the place running. And this is what I spoke of, the dashboard. There's many software programs that tell you how you're doing. So what's my OEE, mean time to repair, mean time between failures? How am I doing relative to completing all the PMs? A larger organization, they may have 150 PMs that are required almost daily across the whole organization. Where are we on those? We're 90-some%. Well, what are we missing? 5%. What are the ones we're missing? And why are we missing those? We can drive that compliance to the PM schedule. Now, how confident are you without this that those would just be being adhered to? In the dark, hidden, and nobody's aware. That is not good, that everyone's not fully aware that the key assets are being maintained properly, at least properly as defined at the current time. So now think about all that around PM, because we never talk about PM. We don't talk too much about it, but we talk about it all the time in terms of OEE. We talk about it all the time in terms of loss. We say we have to run cycle time faster than tach rate because we're not capable. So that very thing that is driving most of that inability is preventive maintenance on our systems. So there's a lot of work that can be done, a lot of structured methods that can be done with PM for key equipment that at least we've got a great system in place. So that's an important thing we can do up front. We don't need to be implementing lean to do this. But these things need to be made sure, we need to make sure that they're in place. Assess lean current state, that's overall. So there's ways that we can assess the entire organization and say, here's where we are. By area, by the lean house. How are we doing on Jidoka? How are we doing on Judoka and Tiger Motors? It's okay. Terrible, right? Right. Not too well. We're trying to do some things, but that's tough. So evaluate all lean systems. 5S. 5S. Graduate team on 5S, raise your hands. Is it a simple thing? Just go clean it up and organize it and sweep it? Not simple? Not simple? No? You learn a lot from what you've been through?
Yes, I have.
What's your confidence level that organizations will just be organized without it? Not likely, right? Not likely. So why don't we go out and why don't we organize our shops? This is not easy. And if you go to a lot of companies, you'll see they're a mess and you'll wonder, why are they a mess? Why don't they just 5S? They actually, I don't think they know how, and I don't think they have the discipline to do it well. This might be a good place to start because it's very straightforward, yet it's something that's probably most likely not complied with. So why don't we just prove to ourselves that we can standardize and organize the operation? Surely we can do that. Still foundational stuff. Then standardize all things to include management work. What does the supervisor do every day? What's standard? Do we check risky process with layered process audits? Do we have a list, a one-page list that we check off and make sure key things are addressed every day by managers? And of course, we're talking about standardizing operations, standardizing work, detailing everything. If standardization is done well, deviation can be seen in all aspects of the business. With 5S and standardization, you should be able to walk through a shop and see deviation easily. And you can walk into most factories and you'll have no idea what's going on. You won't know what they make, why they make it. You won't understand why they're failing. It'll be a mess. It's disorganized because you don't have these systems in place. So you can't manage. You can't lead. You can't teach the standard because there's one not there. So again, this is foundational lean. Ensure there is a system in place to quickly update standards from the process level. What this is saying is if you're working in your process and you come up with a better way to do your job, remember what I said, you don't change it. You do it the inferior way, but you update the standard. So it should be very seamless for you, the process owner, the person doing the work, to be able to get that standard updated rapidly. So ensuring the methodology for improving and updating the standard is quick and efficient and simple and everybody has the ability to participate in it is key. So if you're an organization and that's a good test, hey, we want to change job B because of this. Change job B. Watch how it happens. And you might find out that there isn't a system there. It's word of mouth. And let's hope the quality engineer sees the merits of my idea, if they have time to even speak to me. Then you realize you really don't have a structure in place to rapidly improve your standards. Get that in place. Yes?
I'm not really sure how relevant this is, but in terms of like standardization and 5S, you're talking about creating these systems and implementing this. How do you kind of combine that and bring it together with the emphasis on like having the people working the system being the ones solving the problems and creating things? Because this sounds a little more like you're walking in and saying, we're doing 5S here now.
You mean 5S or standardization or both?
Well, kind of in a general sense, but you could say for the sake of argument, like you want to, your factory's a mess, you want to implement 5S, something like that.
Okay, team structure.
Okay.
So I've got 10, 12 people, I've got a team leader. Team leader has available time to participate in these activities. They have to jump in on a job if somebody's absent, obviously. But a team leader, and all your employees are trained on these methods and more importantly, the why we do these things, so that they understand in the grand scheme of things why we're all trying to do this. And they're trained specifically on some of these methods. Team leaders may be highly trained on the 5S process. So their responsibility would be in their own particular work group that they work on the 5S activity, I would say. That's a possibility. They need to have time to be able to participate in it. A lot of times in factories you don't have a team structure and people can never work on these things. They're not available to do it. And it's one of the reasons the team structure is so critically important, because if people are going to participate in converting their workspace and highly standardizing their operations, they need to have the available time to do it. And so that's the best way to do that. Team leaders, I think, and well-trained and supported. The support part, remember the continuous improvement board. Team leader says we need labeling. We need something to do the labeling with. We can't label our equipment, therefore we can't 5S our area. Assigned responsibility to so-and-so by this date. Now they have a way to get what they need to do the work that they want to do, that they understand because they were trained. And then and another point around this is if one of the training aspects of this, you may pilot an area and say, we're going to take this department and we're going to do this very, very well. Then we're going to bring other team leaders from other areas and train them on 5S and show them what we've done so that they're aware. So they're aware and they understand it, and now they have access to the resource through the problem-solving continuous improvement system. But it's a good question. It's not easy. It's a good question. Drive the Judoka pillar. Now that's I'm not even going to get into that one, right? Because that's all the things we talked about. How do we create process that can't fail in station? So we're looking at like 3D fixtures to control cell 1, and we're trying to get a better 3D printer. I think we can do that. 3D control fixtures in cell 1. So while you're building in cell 1, you cannot make a mistake because a block can't go but anywhere but one place. And so you have these 3D fixtures printed that are customized to all 5 stations. I'm error-proof. Then when it goes to cell 2, we have little Raspberry Pi cameras that are inspecting to make sure all the blocks are correct. So that's mistake proof, but it's still Jidoka. I might make a mistake, but I know it in station, I can fix it. And then when we go to cell 3, we may just have andon. Pull the cord if you see it, but we know people don't see defects, right? So we have a robot at the end with a camera fixed to it that's doing an inspection before we deliver it. But now I don't have Jidoka, but I have control within the cell. So I've implemented other things besides train real hard and be real careful, right? How does that work for everyone? Here's a really well-developed work instruction. You may disagree with that, but here's a really well-developed work instruction. Train really hard and don't make any mistakes. Does it work? Doesn't work. Will it ever work? No, it'll never work. So there's other things that have to be done around Jidoka besides just creating great standards and training people on the standards. There's other things that have to be done if you want to be great. And we're working on it. It's not easy. This is very difficult. Ensure a level of stability that allows for predictability. Only then can we effectively implement a full system in JIT. Now, we've implemented it in the lab. We've got Hijunka and Kanban, but theoretically, you're trying to solve these difficult problems you have with defects and loss and mistakes, because when you're planning your system and you're sizing your supermarkets and you're determining your response time, you must have some level of reliability when you're doing the calculations on how you can respond. If you have wild variation in your quality that you can't control and you can't predict because you're not stable, it makes it very difficult to trust a system that you've calculated and set in place. So we slightly got the cart before the horse. Only in that Jidoka is so difficult to implement, and we're still trying to do that well. But of course, we want to show you a pull system with Kanban. Now drive the JIT pillar, and as you remember, I'm sure you remember very well, these are the 7 steps, and driving just in time. Produce to your tack time. And what does the customer want? How often are they loading the truck? How often are they relieving inventory? Develop continuous flow, one-piece flow. Use supermarkets to control production where continuous flow doesn't extend upstream. We can't do continuous flow. Okay, how big is a supermarket? There's a formula for that, right, Kirsten? Yeah. And so we size our supermarkets. We're still implementing a pull system. Try to send a customer schedule to only one process, station 11, pacemaker. Distribute production of different projects evenly over time, leveling the production mix using Hijunka. Create initial pull by releasing and withdrawing small consistent increments of work at the pacemaker every 6 minutes. Here's what you build in this order. Develop the ability to make every part every day, then every part every shift, then every part every hour, pallet or pitch. That means we implement SMED. Why? So that we don't have to build 20 cars, change over the fixture, and build 10 more. So if we can change the fixture over in 2 seconds, we can build 2 of one or the other. What's that do? Reduces the supermarket. Reduces the WIP throughout the whole system. Achieves the goal of reducing our lead time, because lead time's a function of WIP.